Hey everyone, welcome back to yet another session in the Java series. Continuing our discussion on the functions and the methods concepts, it is time that we dive into yet another important concept called as method overloading. This happens to be quite an important concept, not just from an interview point of view, but also as a software developer. It is extremely important that you are aware of this particular concept because as a developer, there are going to be many benefits that you will be able to reap provided you're familiar with this particular concept. But then, what really method overloading is, what are the advantages it is going to bring to the developer's table, and as a developer, how will I be able to reap its benefits in the software development process? Everything around it definitely you will be understanding by the time the explanation is going to complete. Now, to start with, even before I get into the programming aspect of how to implement method overloading, there is an upfront statement that I would like to make with respect to this concept called as method overloading. And what is it, sir? This is what the statement is, which is method overloading promotes virtual polymorphism. I understand this seems to be quite a heavily loaded statement here. As of now, it might not be making sense to all of you. But by the time the explanation on method overloading would complete, everything in this particular statement would make absolute sense to you. Anyways, let us immediately jump and understand what is overloaded in method overloading. Now, just like any other concept, let us also understand the concept of method overloading with the help of a scenario. And what is the scenario here, sir? I am sure all of you are already able to notice the calculator application on the screen. Now, in this calculator, if I would ask you this, will I be able to add two integers like this? Absolutely yes, 10 plus 20 is nothing but 30, and definitely the calculator is yielding us the right values here. But then, is it mandatory that every time to perform the addition operation, the operands, the arguments should always be integer values itself? What do you mean to say, sir? For example, this time, if I would like to add 12.5 plus, let us say 20 like this, in which case you're able to notice one happens to be a real number, the other operand happens to be an integer value. Is such a addition permissible through our calculator applications? Absolutely yes. You can see it is definitely yielding us the right value as the result. Not only this, is it compulsory that every time you have to provide exactly two operands to the addition operator here? Certainly not. I understand minimum two operands have to be supplied, but beyond two operands, any number of operands can be provided to perform the addition operation. What do you mean to say, sir? Maybe this time I would like to add 15 plus 60 plus 25. Is it able to perform the addition operation for three different arguments this time? Certainly yes. I hope you're able to notice the different permutations and combinations with respect to the number of arguments and the type of the arguments that are supported through our calculator applications. This is exactly what I would like to simulate within my program, through which I would like to explain the concept of method overloading. Once again, a calculator can perform many different operations, but to start with, let us restrict ourselves only towards the addition operation. But then this happens to be quite a powerful addition operation because it should be able to add two integers, one integer, one floating point value. It should be able to add two floating point values. It should be able to add three integers and many other different combinations. How do we do it? Let us understand that. Now, let us understand how do we implement this addition scenario programmatically. To start with, I do not intend to directly implement this scenario in the Java language. First and foremost, I would wish to implement the same addition scenario in the C language. And once our C program code is ready, the same code would be modified and it would be translated to our Java code. Hence, let us start by implementing the scenario in C language. We understand that addition operation is basically a task, and we have understood through our discussion on the functions and the methods topic that whenever you would like to implement a certain task, activity, an operation, or a functionality within your program, it has to be implemented in the form of a function. Hence, I would immediately like to create a function within my C program called as the add function like this. And I would say this add function is such a function that is going to be accepting two integer values as arguments. Hence, there are going to be two integer parameter variables that are going to be declared within the add function like this. It is going to be these two parameter variables x and y which are going to be receiving the integer arguments that would be sent to the add function. Next, within the body of the add function, I would like to simply perform the addition operation between the integer values that are present within the variables x and y like this. And whatever is going to be the result of the addition operation, I would like to store it within another integer variable called as res like this. And finally, the add function does not want to keep the resultant value only to itself. It wants to take the value of this result and it wants to send it back to the caller. And how do we return a value from a function? Very simple it is. It is done by making use of the return statement. Hence, finally, I would say return the value of the variable res, which is the result of the addition operation, back to the caller. Now, this is one way of doing it. There is also another approach that is going to be quite efficient. If you notice, within the body of this add function, we have a variable called as res, which is storing the value of the addition result here. But then you see this variable res is being accessed only once throughout your function body here, which is when you're returning the value, that is when the value of the variable res is being accessed. And you understand this quite well that whenever a variable is going to be accessed only once throughout your function body, you don't have to simply waste the memory for that particular variable. Then how can the same thing be accomplished without we explicitly storing the result in another variable called as reser? This is how it is going to be done. Basically, whatever you were returning, which is nothing but the variable res, it was simply holding the result of the addition operation. Then why don't you directly perform the addition operation and at the same time return the result of the addition operation like this? That means once this return statement is encountered, first and foremost, the expression x plus y would be evaluated. And whatever is going to be the result, it is that result which the add function is going to return to the caller. Next word, sir, what about the return type of the add function? You know this is nothing but common sense. Whenever you would like to add two integer values, the result would obviously be another integer value. That is the reason why the type of the variable res was also integer type. Hence, the return type of my add function is going to be integer type like this. I would like to create another add function within my C program. This time, the job of the second add function would be to add one integer value and one floating point value like this. Hence, this is how the add function is going to be created. What about the body of the add function, sir? It is going to be performing the exact same operation, which is the addition operation like this. But then, what about the return type of this add function? Please remember this. Whenever you would add one integer value and one floating point value, the resultant type would always be the maximum data type of your operands. And between integer and float, the maximum data type, any day it happens to be float type. In other words, the expression, once it is evaluated to a constant value, the type of that value is always going to be determined by considering the largest data type of the operands involved in the expression. Hence, the return type of the second add function is going to be simply float type like this. But then, with this being the current state of your C program, if you try to compile your program, immediately there would be a compilation error that would be thrown at your face. And what is the reason behind that, sir? It is a very simple reason. In C language, whose inventor happens to be Dennis Ritchie, he is not going to permit us. He won't allow us to create multiple functions having the same name. This is a rule in his language. In other words, in C language, you have the liberty to create any number of functions. There is absolutely no upper limit to it. But then what you are not allowed to do is you can't create two functions having the same name. This was a rule made by Dennis Ritchie in his language. And please understand, Dennis Ritchie happens to be quite a smart computer scientist. That means there should be some rationale behind he trying to enforce this rule on the C developers. And the reason happens to be quite simple, which is, if at all you would create multiple functions all having the same name, and tomorrow there is another developer who wants to make use of your functions, and if that developer is going to make a call to one of your functions, and if there are multiple function bodies available, it would simply put the compiler in a state of ambiguity, which is nothing but confusion. Hence, to avoid ambiguity to the compiler, in C language, you're not permitted to have multiple functions defined where they have the same name. But you understand this very well. We are Indians. We are quite a smart species. We have this Jugadu mindset within us. Okay, Dennis Ritchie, this is the rule that you're trying to enforce on us. Nothing to worry about. Very smartly, I would like to call the very first add function as add1 like this. And I would like to call the second add function as add2 like this. Problem is solved. Do they have the same names? 100% no. The first add function has a unique name called as add1, and the second add function has another unique name called as add2. Similarly, I would like to create few more add functions within my C program. But sir, isn't only these two add functions sufficient? 100% not. Please understand this. More the number of functions that we have here, the better clarity we would be able to get on the concept of method overloading. Hence, let us proceed ahead and create few more add functions within our C program. I would like to create another add function this time called as add3, and as all of you can notice, this is going to be such a add function that is going to be performing the addition of two floating point values. Similarly, I would like to create another add function called as add4. This time, this add4 function would be adding one floating point value and one integer value. Some of you might say, sir, such a add function is already created within our C program. That function is what is called as add2. Now, please understand, the order of the arguments is also going to be quite important in this case. Add2 would add an integer value with a floating point value. But then the add4 function would add first a floating point value, then an integer value. The order is going to be different here. Next what, sir? Basically, I want all of these combinations to be available for the addition operation here. I would then go ahead and create another add function called as add5. This time, add5 would add two double type of values in the function body here. Next, we would like to create another function called as add6, and add6 happens to be such a function which is going to be adding one integer value and one double type of a value. Next, I would like to create another add function called as add7 for one floating point value and one double type of a value. Next, I would like to create another function called as add8. This time, it would be performing the addition operation between three integer values. Another add function called as add9, which would be adding three floating point values. Another add function called as add10, which would be adding three double type of values. And another function called as add11, which would be adding one integer value, one floating point value, and one double type of a value. And finally, I would like to create the last add function called as add 12, which would be adding one integer value, two floating point values, and one double type of a value. I hope all of you are understanding. Like this, any number of add functions can be created provided the argument list, the parameter list has to be unique. I mean, why on earth would anybody create two functions with the same list of parameters? It is absolutely going to make no sense at all. Anyways, let us say all of these 12 add functions were developed by one of the developers in the development team. Because, as all of you are aware, out there in the real world, within the IT industry, for any real time project, it is not going to be a single developer that would be working on the project start till the end. It is going to be a team of developers that would be working on any given software project. So let us say this developer's responsibility was to implement all of these addition functionalities. That was the module that was assigned to him. And maybe there is another developer who would now wish to make use of the add functions that were created by another developer. Hence, he would like to test those add functions. He would like to execute the addition functionality. Hence, he would start by writing the main function like this. And within the main function, the second developer would first and foremost create few integer, few floating point variables, and few double type variables within his program like this. He would like to create three integer variables called as a, b, c. He would also like to create three floating point variables called as p, q, r. Sir, don't we have to attach the suffix f in the case of floating point values? Please understand that is a syntactical expectation in Java. In C language, there is no such rule. And finally, he would also like to create three double type of variables like this called as x, y, and z. And now finally, the second developer would like to perform the addition operation between one integer value, two floating point values, and one double type of a value like this. We know the function name obviously is going to start with add, but we certainly don't have a single function also whose name is just add. In other words, can you please guess what is the function name if I would like to perform the addition operation for these different values? One integer, two floating point values, and one double type of a value. I have intentionally hidden the code that was created by the other developer. Why don't you put yourself into the shoes of the second developer? If you want to make use of those add functions that some other developer had created, how are you going to remember the names of so many different add functions? And in our example, we had stopped only after add 12. What if in case in the real time scenario, this way there are going to be hundreds and hundreds of add functions? How is it going to be practical for you to remember those many function names? Right, sir, we are able to understand what the problem is. But then, if I have to execute the program, I have to figure out what is the function name here. Hence, I have to get back to the first developer's code and open his code and figure out which is that add function that is going to be adding one integer, two floating point values, and one double type of a value. And I see this happens to be the add 12 function. Hence, I would say I am going to be calling the add 12 function like this. Once the add 12 function is being called, the add 12 function is going to perform the addition operation and it is going to return the result back to me. And within my main function, I would like to hold that result, which happens to be double type of a value, within another variable called as sum like this. And in the next line, I would simply print the value of the variable sum onto the output screen. The format specifier here happens to be long float, which is nothing but percentage %lf. But then once again, if you carefully observe here, the variable sum is being used only once throughout your main function. Hence, simply don't waste the memory for this particular variable. Can we optimize in this case also? Certainly yes. How can this be optimized? Do not call the sum function separately, store the result separately, and then print that result in the next print statement. Why don't you do all of these things in a single print statement without the need of storing it within a explicit variable? That means this is what I'm talking about. Whatever add 12 function is going to return the result to me, that value I would directly send it to my printf function like this, and the same result is going to be printed onto the output screen. Great, sir. Next what, sir? Next what means this time I would like to call the add function for this particular task. And what are the type of the arguments that you would like to send, sir? This time, as all of you can notice, I would like to perform the addition operation between three integer values. First and foremost, do we have such a add function already defined by the first developer? Certainly yes. But then what is the crucial part here is trying to remember the name of the add function, which was not possible. And now when I get back to the developer one's code, I realize the name of the add function, which is going to be adding three integer arguments, happens to be add8. I hope all of you are trying to realize what the actual problem statement here is. Literally, you had to maintain kind of a register to know which function name is going to be performing the addition operation for what list of the arguments, for what type of the arguments the name of the add function is going to be performing the add or addition operation. Anyways, moving on, let us say this time I would like to perform the addition operation between two double values. Can you please guess what is going to be the function name? Absolutely correct. This time the function name happens to be add5. And finally, if I would like to perform the addition operation between one integer value and one floating point value, can you please guess what is going to be the function name? Absolutely correct. This is nothing but our add2 function like this. In other words, this is the limitation of the C language. Since in Dennis Ritchie's C language, I am not allowed to create multiple functions with the same name, this simple rule is going to put we developers into a lot of trouble because we see all of these 12 functions. Can you tell me what is the commonality between them? The similarity between all of these 12 functions is all of them perform the same task, which is the addition operation. Though they perform the same task, but only because their parameters are going to differ. In C language, I am forced to name all of these functions with unique names. Hence, definitely the limitation of this approach is it is not going to be user friendly. For another developer who has to use your functions, it is definitely not going to provide ease of use to me. It is not flexible to me. But then this is the case in C language. What about in other languages? We understand that the successor of C language happens to be C++. And the inventor of C++, who is Jarnes Troostub, his intent clearly was to mitigate all of the limitations of C language into his newly created language called as C++. So what is the scenario in C++? Let us understand that. Now, before we understand as to how this problem is tackled in C++, for those of you out there who are willing to type and practice this particular C program, please make sure to include the preprocessor directive statement like this at the beginning of your C program code. Only then your program would be compiled and you will be able to execute your program. This is compulsorily needed as within your program code, you're referring to an inbuilt function called as printf. You're only making a call to that function, but the function body has not been defined by you. That is the reason why it is important that you have to link the standard input output.h header file through the preprocessor directive at the beginning of your program code. Now, moving on, and now let us understand how this particular problem of not being user friendly is going to be dealt with in C++. As we all know, in C language, are we allowed to create multiple functions all having the same name? Certainly not. This is absolutely not allowed in C language. But then, how about in C++? Please remember this, my friends. In C++, whose creator happens to be Jarnes Trostrup, his intent behind creating his programming language was quite crystal clear. It was he simply wanted to overcome all of the limitations of C language in his particular programming language. This happens to be one of the limitations in C language, wherein you programmers are not going to be allowed to create multiple functions with the same name, where every single function is going to be performing the same activity. In other words, this problem has certainly been overcome in C++. So if anybody would ask you this question, in C++, are you allowed to create multiple functions having the same name where all of the functions are performing the same activity? The answer is absolutely yes. And that concept is what in C++ is referred to as function overloading. But then, sir, we would like to take a pause at this point of time because we are a little perplexed at this stage. Because we remember you stating the reasons behind why Dennis Ritchie had made that rule in his language, C language. Because if the programmers are allowed to create multiple functions having the same name, and later on, if there is any other developer who is trying to call one of those functions where the functions have the same name, it would lead to name conflict, as a result of which the compiler would be stuck in a state of ambiguity, in a state of confusion. Hence, in order to avoid this to happen to the compiler, the inventor of C language, Dennis Ritchie, made this as a rule itself in his language. But then, now when you say this is absolutely permitted in C++, are you trying to tell us that in C++, though multiple functions will have the same name, and when somebody is trying to call one of those functions, wouldn't it lead to name conflict? Wouldn't it make sure that the compiler would be stuck in a state of ambiguity? Absolutely yes. Though name conflict would arise in such a scenario also, but the compiler of such programming languages are going to be so smartly coded, they would already be programmed in a way they know how to come out of the confusion. What do you mean to say, sir? Do not worry about it. 6 minutes from now, you will understand everything, whatever I have just now theoretically spoken. Great, sir. That means this limitation of C language has been overcome in C++. Hence, now it is going to be user friendly to the programmers. That means now, if the developers have to perform the same activity in multiple functions, they are not going to be forced to name all of those functions with different names. Now, they are absolutely allowed to create multiple functions all having the same name. Hence, the developers this time don't have to remember multiple function names. But then, how about in Java, sir? Please understand, in Java, I don't know how many of you are able to recollect this fact about Java. When Java was designed and it was ready to be released into the market, one of the names that were suggested for this particular programming language was C+++++. That means all of the good features of its predecessor programming language, which happens to be C++, are supposed to be simply inherited as it is into this particular language. And of course, minus minus there indicates all of the negative features, all of the bad features of the predecessor programming languages were supposed to be discarded in this particular programming language. Now let us concentrate on inheriting the positive features here. Please remember, function overloading concept definitely happens to be one such positive feature that the Java team did not wanted to miss in their programming language. That means, if you now ask me straightforward, Zabi sir, in Java, are we allowed to create multiple methods all having the same name? The answer is yes. And the same concept in Java is not going to be referred to as function overloading. It is simply going to be referred to as method overloading for the reasons that you are already aware of. In simple words, in Java, we can create multiple methods within a class, all having the same name. And this process of creating multiple methods within a class, where all of the methods have the same name, but they differ with respect to their parameters, their parameter list is going to be different, is what, my friends, is simply referred to as method overloading. In simple words, I don't want to once again demonstrate what is function overloading in C++ and how is that the name conflict is going to be overcome by the compiler. Since the same concept is also available in Java, let us directly try to understand what is method overloading and how is that overload resolution is going to be performed by the Java compiler. Right. First things first, let us quickly bring back our C program code. Now, it is going to be within this particular C program that I would like to incorporate changes and convert it into our Java program code. Starting from, we have just now realized that within our Java programs, we are absolutely permitted to create multiple methods with the same name. Hence, now that I see that all of these 12 add methods are performing the addition activity, in Java, there is no such rule that every single method should have a unique name. Hence, realizing this fact that all of these 12 add methods are performing the same activity, I do not want to give them distinct names from add 1 to add 12. In simple words, this time I am going to leverage on the concept of method overloading and I am going to be coding all of the 12 methods having the same name called as add. This is the benefit of method overloading. Anyways, going by the syntax of Java, we also know that Java happens to be an object oriented programming language. That means never ever we have seen any program in Java wherein a method has been defined outside a class. Every single method in Java must and should be enclosed in one or the other class. This happens to be the syntactical expectations of the language. Hence, going by this rule, I would take all of these 12 add methods and I would enclose them within a class called as the calculator class like this. This is what, my friends, is referred to as method overloading. The process of creating multiple methods with the same name within a single class but with different parameters. As you can notice, all of the 12 add methods here, their parameter list happens to be unique. This is what is referred to as method overloading. Now, speaking of the other developer, 100% this time his program also should be converted into the Java code. Starting from in Java, as all of you are aware about the signature of the main method, it is not simply going to be void main. In fact, it is going to be public static void main of string array args. And just like any other method, your main method also must be enclosed within a class. Now, speaking of the other developer whose intention is going to be to use the methods that you have defined within the calculator class. His program code also must be converted from the C syntax to Java syntax. Starting from the signature of the main method, we know that the signature of the main method in Java is not simply void main. In fact, it is public static void main of string array args. Why is it public? Why is it static? What is the parameter of the main method going to serve the purpose? Everything all of you are already aware of. Anyways, just like any other method, your main method must also be enclosed within a class. Hence, I would go ahead and place my main method within a class called as the calculator app class. Next, what's sir? The only other change that should be done within his program happens to be in terms of the floating point variables initialization. wherein you see this time 10.5, 20.5, 30.5, these floating point literals, we are intending to store it within our floating point variables. And we know there is a rule in Java that every single real number by default is going to be treated as double type. But if you're willing to store it within your float type of variables, then compulsorily the suffix f must be attached like this. Next, what, sir? Of course, we know in Java, we can't simply use the printf statements like this. This is also something that must be discarded. Next, what, sir? This is where I would like to test your understanding on the explanation that I have provided so far. Let us say I would like to add these four different values. I would like to add one integer, two floating point values, and one double type of a value. Can you please guess what is going to be the name of the method within the calculator class that I should be invoking? Let me do one thing. Let me hide the calculator class code from all of you. I know all of you might be laughing at me. Zabi sir, you don't even have to hide or show us the calculator class code, because we know all of the methods within the calculator class which are performing the addition operation have got the same name in this case, which is nothing but the add method. I hope all of you are already able to realize the advantage of method overloading. Anyways, let me bring back the calculator class code. You know, it is a rule in Java that whenever from one class you want to invoke the method that is present inside a different class, you can't do it just like this. First and foremost, the prerequisite here is you need to create an object of the other class. In this case, you have to create an object of the calculator class like this. And using that reference calc, which is pointing to the calculator object, you will be able to call the methods that are defined within that particular class. In other words, the add method must be called like this. It is calc.add. Next, what, sir? We know that the add methods within the calculator class, after executing their bodies, definitely they are going to return some result to me. Whatever value they are going to return to me, I am not planning to store it within a variable and waste the memory for that particular variable. Directly, I would like to provide that value to the print statement and let the print statement directly print the result onto the output screen. In other words, I would simply enclose this particular add method call within my print statement like this in my Java program. And since in this case, we are not making use of the printf statement, the preprocessor directive statement that you see at the beginning of the program, it is not even needed since we are dealing with the Java program this time. Hence, that statement also would be deleted. But sir, this time we are making use of system.out.println statement here. This println method also, we haven't defined it. It is a library method that we are using it within our Java programs. Should there be any import statement that must be included? As all of you are already aware of, the body for the println method is going to be present within the classes that are present within the default package in Java, which happens to be java.lang, and that package is by default imported within every single Java program. Hence, you don't have to explicitly import it. But then the $1,000,000 question this time is, we are calling a method called as add that is defined within the calculator class. But then we see in the calculator class, there are 12 add methods defined. So is it not going to lead to name conflict? Is it not going to place the compiler in an ambiguous situation? That is what we need to figure out next. Please understand, this is how the Java compiler has been smartly coded in a way that it knows how to come out of the confusion. These are the steps which the Java compiler is going to follow in order to figure out for this particular method call, which is the right body that it has to bind the call with. What do you mean to say, sir? First and foremost, it is going to use the name of the method to see if that information is sufficient to find out which is the method body that must be executed for this call. In other words, this happens to be the very first step. Can you please guess what is the name of the method here? As all of you can see, the name of the method here happens to be add. And also, an additional piece of information here, you see here that the add method is being called using what reference? Calc. What is the type of calc? Just in the previous line, we have defined it. The type of calc happens to be calculator type. That means Java compiler very well knows if I have to find the body for this particular method, I must look into a class called as the calculator class. This is how the Java compiler is going to do the mapping internally. Anyways, it would go to the calculator class and it would immediately make an announcement to the calculator class. A calculator class, I am looking for a method body whose name happens to be add. The moment this announcement is made, all of the 12 methods that are present inside the calculator class would get activated, and every single method claiming, a compiler, I am only that add method, please give the control to me, please give the control to me, I want my body to be executed. Because they are not wrong. The only information with which you went to the calculator class was the name of the method, that I am looking for a method called as the add method. Correct. All of the 12 method names here happens to be add. Immediately, the compiler is going to be gabrified. He's going to be scared. Hey, how can I give the control to 12 different add methods for one method call? It is a rule in programming. For one method call, only one method body must be binded. Immediately, compiler would run back and come back to the main method. It would come back to the statement where the add method has been called. Now it realizes only the name of the method is not sufficient for me. Immediately, it is now going to pick up one more piece of information. This is the second step which the compiler would be using it in order to resolve the overloaded method here. What is that second step, sir? It is going to take into consideration the number of parameters. That means now the compiler is going to slightly modify its announcement. It would once again go to the calculator class, and now this is how the announcement is going to be made. A calculator class, I am looking for a method called as the add method, and the add method must be accepting 4 parameters. The moment this announcement is made, all of the methods which are accepting 2 parameters and 3 parameters are going to be deactivated. They are going to become inactive, and there is going to be only one single method which would still be standing, claiming I am only that add method, I am only that add method. Now that the compiler is going to notice that for this method call, there is only one method body that is active. No more there is any confusion to the compiler. Why would there be any confusion when you have just one single option in front of you? Hence, immediately for this particular method call, this is the method body that is going to be binded and the execution would proceed. So I hope all of you are realizing, if at all this question is asked during your interviews, that once method overloading is performed, is it going to lead to name conflict? Your answer should be 100% yes. But then the Java compiler has been so smartly designed, it knows very well how do we come out of the confusion. It is by using these steps. Anyways, now let us proceed forward and understand how this particular method call is going to be executed. Wherein, as all of you can see here, this time I want to call the add method on 3 integer values. Once again, let us start from the first step. Compiler would go to the calculator class looking for a method called as the add method. The first piece of information that it is going to be using happens to be only the name of the method. And the moment this is the announcement which the compiler would make, immediately, once again, all of the 12 methods are going to get activated. Immediately, the compiler would come back, and this time it is going to use the second piece of information, which is nothing but the number of parameters. And with this piece of information, now if compiler would go back to the calculator class and it is going to modify its announcement, a calculator class, I am looking for a method called as the add method and it must be accepting three parameters. Immediately, all of the two parameterized methods and four parameterized method are going to remain deactivated. Only these methods which are accepting three parameters are going to remain active. But once again, for one method call, the compiler will not be able to bind four different method bodies. That means the second piece of information is also not enough in this scenario. Then what would happen, sir? Once again, the compiler would come back to the method call, and this time it is going to use the third step here, which is nothing but the type of the parameters. In other words, the compiler sees in the method call that the add method is being called with three parameters where all of the three parameters happens to be integer types. Now with this information, once the compiler would go to the calculator class and it is going to make the announcement accordingly, immediately the rest of the three add methods would get deactivated because those add methods do not have the type of the parameters as integer types. And it is only this add method which is going to be accepting three integer arguments. Hence, compiler is extremely happy and he is celebrating that now finally I have got just only one method body. Hence, for that method call, this is the method body that is going to be binded and the execution would proceed accordingly. Next, let us understand as to how is the Java compiler going to resolve this particular method call. Wherein, as all of you can observe here, we are calling the add method this time by sending two double type of values. As usual, the first information with which the Java compiler is going to visit the calculator class is simply going to be the name of the method. In this case, it happens to be add. And immediately the compiler realizes only with this piece of information, I see in front of me there are 12 add method bodies. Immediately it would get back to the call and it would use the second piece of information. In the second step, it is supposed to use the number of parameters information here. And it notices that the add method is being called by sending two arguments. That means I'm looking for such a add method which has been defined with exactly two parameters. In other words, all of the three parameterized methods and the last method which is accepting four parameters is going to remain deactivated and only these seven add methods which are accepting exactly two parameters are going to remain active. But then, how can one method call be binded with seven different bodies? This is definitely not going to happen. Immediately, the compiler would come back, and once again, it is going to use the third piece of information here, which is nothing but the type of the parameters here. I am looking for a method whose name is add, and it should be accepting exactly two parameters, and both of those parameters have to be double type. And once this is the modified improvised announcement that is being made to the calculator class, immediately out of all of the seven add methods, every single add method which is not going to match the announcement is going to become deactivated, and it is going to be only this single add method which is accepting two parameters and both of them happens to be double types is going to remain active. Hence, the compiler once again goes celebrating all around, telling, look, successfully I have resolved the call to an overloaded method. There is one method call and there is only one method body that happens to be active. Hence, the binding is going to be done and the execution would proceed. Next, watcher, finally, let us figure out how is the compiler going to resolve the last method call like this. Wherein, if you notice this time, we are calling the add method by sending one integer type of data and one floating point type of data. First thing, the compiler would use the name of the method. Once again, we see all of the 12 methods would get activated here. Compiler would immediately come back, use the second piece of information, number of parameters. I am looking for a add method with exactly two parameters. Hence, all of these add methods which are accepting three parameters and four parameters are going to get deactivated. And once again, the compiler would come back and now it is going to use the type of the parameters. A look calculator class, I am looking for a method called as add, which should be accepting two parameters. One of them should be integer type and the other one should be float type. The moment this announcement is made, what do you think? How many add methods are going to remain active? If your answer is 1, you are mistaken. To be precise, even with this piece of information, we would realize there are going to be these two add methods which would still remain active. Both of them claiming my name is add, I am accepting two parameters. One of those two parameters is integer type and the other one is float type. Please tell me if they're wrong. 100% no. That is when the compiler is finally going to release the Brahmastra in this case, which happens to be the fourth step, which is nothing but the sequence of types of the parameters. The order plays an important role in this case. Hence, now with these two bodies still active, the compiler would finally make a final visit to the calculator class. A calculator class, I am looking for a method called as add with exactly two parameters. One of them should be integer type, the other one should be float type. But please note, the first parameter should be integer type and the second parameter should be float type. Now with this precise announcement, immediately this add method is going to get deactivated and there is only one add method that is going to remain active. Hence, for that add method, this is the method call that is going to be binded and the execution would proceed. Sir, after this, are there any more steps involved in terms of how the Java compiler is going to resolve the call to an overloaded method? Certainly not. These are the only four steps which the compiler would incorporate in order to resolve the name conflict during method overloading in Java. Like I said, this is how the Java compiler stands apart compared to any other compilers out there. Even though the name conflict would arise, there is no doubt about it, but the Java compiler is capable of overcoming the name conflict. Hence, there is no way the compiler would be stuck in a state of ambiguity or confusion. This process of the Java compiler, my friends, this is what is referred to as overload resolution. Anyways, I hope all of you have been able to understand as to how can we implement method overloading, and if a call is made to the overloaded methods, how is that call going to be resolved? How is the body going to be binded with the method call? What are the steps which the compiler is going to implement? Everything and anything about it you have been able to understand. Next, what, sir? It is time that we get back to our very first statement that I made with respect to method overloading, which is method overloading promotes something called as virtual polymorphism. Now, what is this virtual polymorphism and how is it associated with method overloading? That is what next we need to understand. Let us now try to decipher the meaning of this technical term called as virtual polymorphism. As all of you can notice, in this technical term, it is composed of two different words, virtual and polymorphism. Hence, let us not try to directly understand the meaning of both of these two words together in this one single term. Instead, let us break down this term into two different words and let us understand their meanings separately, individually, starting from the word virtual. Can you please guess what could be the meaning of this word called as virtual? I am sure it is not a very rarely heard word. In fact, nowadays we get to hear this word called as virtual very oftenly. It has got something to do with the electronic gadgets. You're absolutely right. I'm referring to the VR headsets, virtual reality headsets. And can you tell me How do we use these VR headsets? The moment you happen to put on those VR headsets, you will immediately feel, you will get an illusion as though you are walking in some street of Paris. Maybe you're taking a tour of the Disneyland, or maybe you're standing in front of a pyramid in Egypt, you're shopping somewhere in Dubai, and the moment you take out those headsets, you will realize you're just stuck in Bangalore traffic. In other words, what is the meaning of this word called as virtual? It simply means something that does not have physical existence, something that does not exist in reality, something that is unreal. Great, sir. We understood what is the meaning of virtual. How about polymorphism? Please understand, this word has been derived from two different words. It is a Greek word. What are those two different words, sir? The first word happens to be poly, and the second word happens to be morph. Poly simply means many, morph means forms. In other words, any entity, any object that exists in many different forms is said to be polymorphic in nature. Because please understand, this word called as polymorphism, it is not only associated with computer science. It is a generic term. It is associated with biology as well. It is associated in chemistry as well. In other words, any entity that is going to exist in many different forms is supposed to be called as polymorphic in nature. So, to conclude, the relationship for polymorphism to exist must always be one is to many. One object is going to exist in many different forms. Can you give an example, sir? Absolutely, why not? I am sure during your schooling, your school teachers have told you this, especially during the chemistry classes, that the carbon element is polymorphic in nature. What does it mean? What it means is this carbon element exists in different forms in the nature. What are its different forms, sir? It exists in a form called as graphite. Graphite is nothing but carbon. It also exists in the form of coal. And when the same carbon is subjected to immense pressure, what it is going to create is something called as diamond. So don't you think the same carbon element in the nature, it is existing in different forms? Absolutely yes. That is the reason why carbon is said to be polymorphic, because it very well satisfies this relationship of one is to many. All of you can shift your focus from the diamond to Zabi, sir. I'm explaining something here. Yes, next time when your mother would ask you to go buy a diamond for her, just remind her that it is simply a carbon. Instead of that, maybe you can go to a coal factory, take a piece of coal, put it around a chain, and maybe that would also be a new trend in the fashion. Anyways, jokes apart, maybe another example would help you understand what is meant by polymorphism. Water is also said to be polymorphic in nature because water also exists in different forms. We know that water exists in a state called as the liquid state. We know it also exists in a state called as the solid state. We also know it exists in a state called as the gaseous state. That is the reason why water is also said to be polymorphic in nature, because it clearly satisfies the one is to many relationship. That way, forget about carbon or water. In fact, we are also in many ways polymorphic. Same person, but with different people in different occasions, we are going to behave differently. What do you mean to say, sir? It is the same person, but then out with the friends, you are going to behave differently as a friend. You are the same person, but maybe within your house, along with your family members, you are going to behave differently. I might behave like a son, I might behave like a brother inside my family. And the same person, the moment I would get into my professional life, in my office premises, I am going to behave like an employee there. As you can see, that way we are also polymorphic. That is what I'm trying to convey here. Great, sir. We understood what is the meaning of polymorphism. Any entity that is going to satisfy the relationship of one is to many can be eyes closed called as polymorphic in nature. But then, sir, how is all of this, the concept of virtual polymorphism, related to method overloading? That is what I would be explaining next. Right. Let us get back to our program code. This time, I want you to look at the overloaded add methods defined inside the calculator class from the perspective of this second developer. And how is this person going to look at those overloaded methods, sir? Please understand, he is somebody who is not at all aware of what is present inside the calculator class. He is not the one who has defined those overloaded methods. He is simply going to call the method called as the add method. He is only going to invoke the methods. Basically, he is somebody who is not aware of what is present on the other side of the wall. What do you mean to say, sir? This is what the second developer feels. He thinks there is just a single add method defined inside the calculator class which is able to perform the addition operation for different types of parameters. It can add two integers. The same add method is also performing the addition operation when I'm going to send one integer and one float type of a value. And the same add method is also capable of adding two floating point values. In other words, literally, this developer is in love with the add method. He feels what a wonderful add method the other developer has coded. It is working perfectly fine for different types of parameters that I'm sending to it. The same add method is also capable of performing the addition operation between one floating point value and one double type of a value. The same add method is also working for three integers as arguments. It is only you and I who are aware of both sides of this story. We know that inside the calculator class, we don't have a single add method that is working for multiple different types of parameters here. In fact, we know that there are multiple add methods with multiple different sets of parameters. But then for the second developer, the story is entirely different. He feels that this add method is polymorphic in nature because it is clearly satisfying this equation of 1 is to many according to this developer. One method which is working for different types of parameters. But think and answer. Whatever his presumption is, do you think it is right or wrong? Absolutely correct. It is just an illusion to the second developer. The person who is going to use my overloaded methods is going to feel as though there is just one single method, because anyways the name is going to be same. But since it is working for a different set of arguments, the other developer gets an illusion as though there is just a single method which is performing multiple activities here. In other words, they feel the relationship happens to be 1 is to many. See, it is something like this. Maybe you will understand it better with this analogy here. Let us say you're about to complete your graduation, but just before you graduate, the placement season has been kick-started. And because you were enrolled into this particular course, cracking some of the top notch product based companies was a cakewalk for you. And soon after your graduation, you have decided to go with one of the product based companies. You have joined the company and you have started working as a full stack software developer. You realize that just from the beginning of your career itself, you have seen illustrious success in your professional life. So far, it's been around 6 years for you within the IT industry working as a software developer. And if there is one thing that you have realized throughout this period of 6 years of professional life, that is because of the work pressure, Because of the familial responsibilities, you have eventually lost contact with your childhood friends. And while you were realizing this, one fine day, your phone has started ringing. And the first thing that you're able to notice there is it is one of your childhood friends who's trying to call you. Out of excitement, you immediately answer the call. Once after exchanging the greetings, you start to learn that your friend has chosen a completely different, unique path in his professional life, which is he has decided to carry forward his father's garment business. And the business which his father used to run with just one showroom, your friend has been able to successfully expand it to three different showrooms in a metropolitan city like Bangalore. You're extremely happy for your friend. That is when your friend would reveal the purpose of the call. You might have forgotten all of the childhood times, the good times that you have spent with your friend, but your friend has definitely not been able to forget those memorable moments that he has spent with you. And it is only to cherish those moments the call has been made to you. In other words, the reason why your friend has called you is to invite you as a chief guest for the opening ceremony of the fourth garment showroom in the city. You are overjoyed. You can't believe that you are being invited as a chief guest because you feel nothing great you have done so far in life. It happens with all of us. And finally, once the call was disconnected over the WhatsApp, your friend has shared all of the event details with you. Finally, this event day has arrived. You get ready from your place, you book an Ola auto, and you immediately commute to your friend's garment showroom. The moment you get down from the auto rickshaw, you see there is a red carpet that is laid in front of the showroom, and there are a lot of dignitaries who are already waiting for your arrival there. The moment you arrive, the scissor is going to be handed over to you, and the moment you cut the ribbon, every single place from every single angle, there are snaps that is being taken of yours. Immediately, your friend would take you inside the showroom. And you also realize since it is the opening day of the showroom, your friend has announced some of the quite luring offers to the customers. 50% discount, buy one, get one free. And because of this, there is a huge line that is queued outside the showroom. So immediately, your friend would escort you to the office, to his chamber that is built in the third floor of the same building. And you immediately go take a seat in his chamber. And from the place where your friend is seated, just behind you, there is a huge TV that has been placed. Basically, he has created something like a war room. Through his chamber, he will be able to monitor every single thing that is happening within his showroom through the CCTV footage. Next, what, sir? Now your friend realizes that he has forgotten to offer you any sort of welcome drinks. So immediately he takes his phone, he gives a call to a person called as Ramu. Hey Ramu, please bring soft drinks to both of us. Immediately after 2 minutes, you see the soft drinks were brought by Ramu. It was handed over to the housekeeping staff of the third floor, and the staff has started serving to both of you. But in this scenario, you did not get to see who that person Ramu was. While you're speaking, while you're having a chat with your friends, you realize your friend is noticing that there is a customer in the second floor who has left unattended for quite some time. So once again, your friend would take his mobile phone and he would immediately ring to a person called as Ramu. Ramu, please attend the customer who's waiting in the second floor. Once again, your friend notices that there is a customer who's waiting in the ground floor for the billing. So once again, your friend would give a call to a person called as Ramu, and he would instruct Ramu to do the billing at the cash counter. and you finally realize that it is time you have to take a leave, because there is a sudden production issue that has popped up which would require your immediate attention into the issue. That is how the life of a software developer is. And your friend would inquire with you, how are you planning to commute back to your place? You would say that I'm planning to take an auto rickshaw outside the showroom. So once again, your friend, in order to honor you, once again he would call this person called as Ramu, and he would ask the Ramu to hold an auto rickshaw for you. Finally, you would come out of the showroom and you have taken the auto rickshaw back to your place. Now, while you're traveling back to your place, if there is one person who is stuck in your mind, it is not your friend, it is that person called as Ramu. You feel your friend has been blinded so much with success. In order to save few pennies, your friend has become inhuman. Your friend has recruited just one poor fellow called as Ramu, and he has overloaded Ramu with multiple jobs. And you feel it is your moral responsibility to open your friend's eye. That is when you would immediately give a call back to your friend, and you would express your concern that your friend is being inhuman by overburdening this one poor fellow called as Ramu. The moment your friend would hear this, he is laughing out loud. And what is the reason behind that? When you're wondering it, your friend would say, look, brother, you're absolutely mistaken. Actually speaking, there is not a single person called as Ramu that I have hired here. There are many different individuals that I have recruited for this particular showroom. And the day when I hired the staff for this showroom, I happen to be quite a busy person in life. I will not be able to remember the names of the entire staff since this happens to be the fourth showroom. Hence, I decided to name each one of them as Ramu. And this was very well communicated to them. And I had also given another instruction to each one of them that when I say Ramu, all of you would be activated. But when I say Ramu, bring coffee, only that person that was hired to bring tea, coffee, soft drink, snacks is supposed to do the job. When I say Ramu, once again everybody would get activated. Then when I say attend the customer, only that person who was hired as a salesman would do the job. When I say Ramu, do the billing, only that person who was recruited to sit at the cash counter is going to do the job. But then, for the sake of simplicity, I have simply named every single person here as Ramu. That is when you would feel sorry for misunderstanding your friend and you would immediately disconnect the call. Now you're thinking, no reason why your friend is so successful in life, because he is one of the smart fellows you have ever come across. The point of this analogy is very simple. Just like the second developer, you were also having this illusion that there is only one person called as Ramu who is doing multiple different jobs. But in reality, there were many different individuals doing different jobs on their own. In other words, now that you have realized as to how this analogy is relevant to our concept of method overloading, it is time that we take up another example and see how a person can have an illusion about something that does not exist in reality. But before we move on to the second example, I would like to reveal the garment showroom that I was talking about. And as all of you can notice, I have named this garment showroom after the founder of Java, the father of Java, James Gosling, and I have called it as James Bazaar. Of course, the entire credits have to be given to he and his team for creating such a wonderful programming language. A language that has ruled the programming community, that has been ruling the programming world for almost 3 decades now. Anyways, moving on to the next example, I am sure all of you have heard of this optical phenomena in physics called as highway mirage, wherein you happen to see on a sunny day at a certain distance from you, you see there is some watery image ahead of you. And the moment you start moving close to it, you see there is no such water ahead of you. Basically, it is an optical phenomena which involves the concept of refraction of light. It happens when the temperature on the road is going to be more than the temperature of the air above it. Let me not get into the physics of it. This is also a type of illusion. Coming back to our example of method overloading here. Now that we have understood as to how the second developer here has an illusion that there is just one single add method that is able to perform the addition operation for different set of arguments here. In other words, this is just an illusion. This is certainly not the reality. In reality, we know that there are many different add methods performing addition operation for many different sets of parameters. And if I would reduce this equation, if I happen to simplify this equation, it is nothing but 1 is to 1. That is the relationship that we are talking about here. Finally, to conclude, this is the relationship in reality. That means one add method is performing the addition operation for one set of parameters. It is not the case where one add method is performing the addition operation for multiple different sets of parameters, just like the way the second developer had the perspective. Hence, to conclude, think and answer. Is this true polymorphism here? 100% no. It is just an illusion to the user that one method is performing many different activities. Hence, to conclude, this is not true polymorphism. This is virtual polymorphism. This is the meaning of the technical term called as virtual polymorphism, unreal polymorphism. Virtual polymorphism in Java is also referred to as compile time polymorphism. Now, what really compile time polymorphism is, let us understand that next. How compile time polymorphism is achieved in Java using the concept of method overloading is a question that you won't be able to skip during your interviews. Now, let us understand what is really meant by compile time polymorphism through this sample program code, wherein you see in this particular code snippet, the add method has been overloaded. Of course, this time I wouldn't wish to present the entire complete code here, because this time let us not focus on the syntax. It would simply be a waste of our time. Let us focus on the concept here, which happens to be compile time polymorphism. Hence, let us say this is how the add method is being called by sending two floating point values as arguments. As all of us know, it is going to be the duty of the Java compiler using those four steps. It has to figure out for this particular method call, which is the overloaded method body that is going to be binded together. And once those four steps are going to be applied by the Java compiler, immediately it is going to realize this is the method body that is supposed to be binded for this particular overloaded method call. Now, one important point to be noted here is, please understand, at the time of compilation, it is only the decision which the Java compiler is going to be taking, that look, if at all tomorrow, if this code is going to be executed for this particular method call, this is the method body that is supposed to be executed. But if you also ask me, would the execution also take place at the time of compilation itself? This is quite a silly question to be asked, because we know at the time of compilation, it is only the compilation task that is going to be performed. Execution won't happen at the time of compilation. Then when is the execution going to happen, sir? Please remember this: execution would happen during the runtime. And who is the one who is going to execute our Java programs? We already know this. It is the JVM. Now, while the JVM has to execute this particular method call, the decision was already taken during compilation time. It simply has to pass over the control of execution to this particular add method, and the add method is successfully going to be executed. So these are two important observations to be made here, that the decision would be taken during compilation time, but execution would happen during runtime. And at the time of execution, JVM is not going to scratch its head in order to find out for this method call which method body to be executed. It is simply going to rely on the decision that was taken by the Java compiler. This is the reason why, my friends, this polymorphism is also referred to as compile time polymorphism. It is also referred to as virtual polymorphism. It is also referred to as static polymorphism. Why is it called as static polymorphism, sir? Because the decision that was taken by the Java compiler at the time of compilation, it was fixed, and it is not going to dynamically change at the time of execution during runtime. Hence, it is also referred to as static polymorphism, compile time binding, static binding, early binding. You will realize going forward in the course, there is also something called as runtime polymorphism, real polymorphism, dynamic polymorphism, and that is not going to be achieved using the concept of method overloading. That is going to be achieved using the concept of method overriding. When time arrives, that is when that concept is going to be discussed. As of now, this is the reason why we say compile time polymorphism in Java is going to be achieved using the concept of method overloading, because the overloaded call resolution is going to be done at the time of compilation, and whatever decision was made during the compilation time, that remains static, that remains fixed even at the time of execution. Anyways, I hope everything about virtual polymorphism and compile time polymorphism you have been able to understand. After having explained the concept of method overloading in such a detailed manner, before I conclude, I would like to assess your understanding on the same concept here. So please carefully observe the next code snippet, because it is going to be you who has to predict as to what is going to be the output of that particular code snippet. This is the program code wherein I would like to create a class called as the calculator class like this. Within this class, I would like to define a method called as the add method, which is going to be accepting two integers as parameters. And within the body of the add method, as all of you can notice, I am simply returning a constant integer value called as 30. Hence, what do you think must be the return type of this add method? Undoubtedly, it has to be integer type like this. Since in Java, there is a concept of method overloading wherein I am allowed to create multiple methods within a single class having the same name, I would like to go ahead and create another method called as the add method with the exact same parameter list wherein there are two integer parameters, but this time within the body of the add method, as all of you can notice, I am going to be returning a constant floating point value called as 30.5. So what do you think must be the return type of the second add method? Absolutely correct. This time it has to be float type. And this is how the execution code is going to be written within a different class called as the calculator app class, within which first thing I would like to define my main method like this. And within the main method, I would first create an object of the calculator class and assign a reference called as calc to it. Now, in the next line, using that reference calc, I would call the add method by sending two integer values called as 10 and 20. But most importantly, after executing the add method body, whatever result it is going to be returning to me, I would like to collect that result within a variable called as res, which is going to be of float type. And finally, I would simply print the value of the variable res onto the output screen. You have got exactly 30 seconds from now to predict the output of this program code. Whether is it 30 or is it 30.5? Time's up. If at all your output happens to be either 30 or 30.5, both of these answers are absolutely incorrect. And why is that so, sir? First, understand what is going to be the output. You will get a compilation error for this particular program, because please carefully look at the add methods within the calculator class. Can you please tell me, with respect to the signature, is there any differentiating factor? Certainly not. You might say the return types are different. That is the exact point that I'm trying to highlight over here. The name of the methods happens to be the same. In fact, their parameters also happens to be the same. The only way that they are differing here happens to be with respect to their return types. The first add method has the return type as int. The second add method has the return type as float. It doesn't really matter what the return type of a method is. So the conclusion here is return types do not have any significance in the process of method overloading. In other words, understand this golden statement. We cannot create two methods with the same name and with the same set of parameters but with different return types, because return types in a language like Java do not play any role at all. Of course, return types in C++ function overloading has a certain role to be played, but in Java, it is only the method signature that is going to be used at the time of overload method resolution by the Java compiler, and the method signature excludes the return type. It simply includes the method name and its parameters. So I once again repeat, if you have created two methods with the same name but with the same set of parameters, but they differ only with respect to their return types, such methods are not going to be allowed in Java, because return types in the process of method overloading don't have any role to play at all. This is the reason for the compilation error to be generated for this particular program code. Hence, one must be extremely careful while analyzing such tricky code snippets, especially during your aptitude rounds in your placement interviews, wherein these days in your aptitude round itself, there is going to be a section there called as technical aptitude, where such small code snippets would be given to you and you have to analyze and predict the output of such code snippets. And intentionally, they would lay down a trap for you by creating such methods with the same name, with the same parameters, but intentionally they would have assigned different return types. You have to immediately be able to remember this rule, that in Java, for the process of method overloading, return types don't have any significance at all. That means, straightforward, whenever you see two methods with the same name, with the same parameters, immediately the output would be a compilation error. Finally, one last question before we conclude the explanation on method overloading, which is, in method overloading, what really is overloaded? Whenever I would ask this question to my students, their instant answer would be, sir, very simple, sir. The answer lies in the question itself. In method overloading, methods are overloaded, which is absolutely incorrect answer. Tell me, in that Ramu scenario, was Ramu overloaded with multiple jobs? 100% no. What was overloaded there? Only the name of the person Ramu. And now, when you say in method overloading, methods are overloaded. That means what you mean to say here is one single method would be performing multiple different activities. That is not the case here. So, what is the right answer to this question, sir? In method overloading, it is only the method names that are overloaded, not the methods. So, please give it a thought before you answer to such technical questions in your interviews. Do not treat your interviews like your Viva exams, where I have seen many instances of these students trying to answer to such similar technical questions. For example, if a question is being asked as to what is a data type, this is how the students would tend to answer. Type of the data is referred to as a data type. What is overloaded in method overloading? Instantly, methods are overloaded in method overloading, which is absolutely an incorrect answer. In method overloading, it is only the method names which are overloaded. Basically, an illusion would be created to the user of the overloaded methods that there is just one single method which is performing multiple different activities. In other words, it is presumed that the relationship happens to be one is to many, it is polymorphic. But we know that in reality, there are multiple methods all having the same name, but performing one activity each. That means in reality, the relationship is not one is to many, the relationship happens to be one is to one. Hence, this is the reason why we say that method overloading promotes virtual polymorphism or compile time polymorphism. Anyways, before I officially conclude the explanation of the method overloading concept, there is one last code snippet with which I would like to assess your understanding. This is how I would like to code my program, wherein I would like to create a class called as the demo class. I would like to define a method called as the display method, which is going to be accepting one integer type and one float type as the parameters. And since it is not going to return anything back to the caller, obviously the return type is going to be void. Next, I would like to overload the display method like this, wherein the second display method is going to be accepting one integer type as the parameter and one double type as another parameter. Next, I would also like to create another class called as the launch class, within which I would like to define my main method like this. And the first thing that I would like to do within the main method is create an object of the demo class. Next, I would like to prepare two variables within my main method like this, where one happens to be integer type and the other one happens to be long type. And finally, I would make a call to the display method like this. So what do you think is going to be the output of this code snippet? If at all your answer happens to be compilation error, because sir, there is not a single display method which can be accepting one integer type and one long type as the argument, because there is no such method defined in my demo class. You're absolutely wrong. In such a case, in method overloading, whenever exact match is not found, the compiler would not immediately generate a compilation error. Instead, the compiler would try to find the closest match by performing something called as type promotion, nothing but implicit typecasting. I am sure all of you are aware of the implicit typecasting chart. Now let us get back to the method call, wherein the first argument happens to be integer type and the second argument happens to be long type. And when I look at the display method definitions, the first parameter is very much eligible to accept the first argument. But then what about the second argument, which is going to be long type? Now you might say, sir, the second argument also can be received by both float type as well as double type. You're absolutely correct. though the exact match is not going to be present, the compiler would try to perform typecasting. It would promote the type of the data and it would try to fit in one of the eligible parameters. But sir, you just now mentioned that both of them, both float type as well as double type of parameters, can receive long type. Then once again the confusion arises for the compiler in this case. Please understand, the compiler looks out for the closest match between float and double for long type of data. Look at the chart here. Which one do you think is more specific, is more closest option here? Absolutely correct, it is the float type. In other words, for this particular method call, the output is not going to be compilation error. Though the exact match is not found, even then the compiler would perform implicit typecasting and it is able to find the closest match. In this case, it happens to be the first display method. Hence, the output of this program code is going to be cool. This is what, my friends, is referred to as method overloading with type promotion. This is exactly what happens to many of us whenever you happen to approach a pharmacy with a doctor's prescription. In the absence of the medicine of the exact brand, the pharmacist wouldn't simply say that the tablets are not available. Instead, the person there would try to approach you with the alternative option that, look, sir, the tablets of the exact same brand are not available. But nothing to worry, the same composition for the tablets, it is available from a different brand. Would you like to purchase those tablets? It is exactly the same thing that is happening here. Exact match is not found. Look for the closest match. How to find which is the closest match? Implicit typecasting is the way to go. Finally, the time has come to bid goodbye to the concept of method overloading. I believe all of my learners have been able to thoroughly understand this concept of method overloading. Was this concept supported in C language? Is it supported in C++? How do we implement it in Java? Because multiple methods are going to have the same name. Is it going to lead to name conflict? If so, who is going to resolve it? And how is the Java compiler going to resolve it? What are the steps it is going to be applying? How does it promote something called as virtual polymorphism? What is meant by compile time polymorphism? What is meant by static polymorphism? Do return types have any significance in method overloading? What is meant by method overloading with type promotion? And most importantly, what really is overloaded in method overloading? And much more you have been able to understand throughout this entire explanation. So I would like to conclude this topic by finally giving you an assignment on method overloading. It is up to you to analyze this code snippet and predict the output of the program code. A last piece of advice, make sure to revise on a daily basis. Only then you will be able to remember and recall all of these information at the time of your interviews. Thank you so much everyone. Happy learning.